In square ABCD, E is the midpoint of AD. Construct a circle between the 3 points E, B, and C. Which shape has the larger perimeter, the square or the circle?
We have a circle and a square with two corners touching the circle and one side tangent to the circle. We want to find out which perimeter is larger, the perimeter of the circle or the perimeter of the square. From the beginning, we can observe the right angle marked in red. It is a right angle inscribed in the circle, which means that its hypotenuse will be the diameter of the circle. Let's consider a square with a side equal to 1 unit. We will denote the diameter of the circle as d and the left leg of the right triangle as x. Applying the Pythagorean theorem in this right triangle, we find that the square of d equals 1 plus the square of x. We can construct the following diameter of the circle. The piece marked in red will be equal to the entire diameter of the circle minus the side of the square, or d minus 1. By drawing the next horizontal line, we can see that the distance marked in red from the upper part is equal to that from the lower part, also d minus 1. We can observe that x will be equal to the diameter of the circle minus the two red pieces. So x equals d minus 2 times d minus 1. Now that we know what x is equal to, we can manipulate the formula to obtain x equals 2 minus d. We replace the value of x in the initial formula and obtain that the square of d equals 1 plus the square of 2 minus d. Solving the equation, we find that the value of d is 5 over 4. We also know that the square has a side of 1. The perimeter of the square will be 4. The perimeter of the circle will be pi multiplied by the diameter, or pi times 5 over 4. We can multiply both perimeters by 4. The perimeter of the square will become 16, and the perimeter of the circle will become 5 times pi. Pi is approximately 3.14, so the perimeter of the circle will be around 15, therefore smaller than the perimeter of the square, which is 16. So the perimeter of the square is larger than the perimeter of the circle.
I'm going to present 3 different ways to solve this problem. Let's get started with the intersecting chords theorem. To begin, we'll construct the perpendicular bisector of the top side of the square. Since point E, this top point, is tangent to the circle, this perpendicular bisector is a diameter of the circle. It also bisects the bottom side of the square. So if this length is equal to y, this length will also be equal to y, and the entire side of the square will be equal to 2y. If we write r for the radius of the circle, then 2r is the diameter of the circle, and the remaining distance on the diameter is equal to 2r minus 2y. Now we can use the intersecting chords theorem. We must have 2y multiplied by 2r minus 2y is equal to y multiplied by y. Let's simplify this equation. We'll first distribute, and then we'll group like terms. We'll then factor y, and we can then solve this equation. Y is either equal to 0 or y is equal to 4/5 r. Since we want y to be a positive value, so the square side has a positive length, we reject y is equal to 0. Therefore, y is equal to 4/5 r, which means r is equal to 5 over 4y. Let's now calculate the square's perimeter. A side of the square is equal to 2y, which means the perimeter is equal to 4 multiplied by 2y, which is equal to 8y. Now let's calculate the circle's perimeter, or its circumference. That'll be equal to 2 pi r. Now r is equal to 5 over 4 multiplied by y, which means 2 pi r is equal to 5 pi over 2 multiplied by y. And this is approximately equal to 7.85y, which is definitely less than 8y. Therefore, the square has the larger perimeter. Now let's proceed to the next method, which uses a property of right triangles. We'll proceed like method 1, where we have the perpendicular bisector. Notice this will also be perpendicular on this side of the square. We'll label the lengths as before, and now if this is the center of the circle, this length will be equal to r, and this length will also be a radius of the circle. Now, if this distance is equal to x, what must x be equal to? Well, we want the entire side of the square to be equal to 2y. Therefore, we must have x plus r is equal to 2y, which means x is equal to 2y minus r. We now consider this right triangle. By the Gogu theorem, we have 2y minus r, the quantity squared, plus y squared is equal to r squared. We can then simplify this equation, and just like before, we end up with a very similar equation. We have two possibilities, and we reject y is equal to 0, and this proceeds just like before, where we calculate the perimeter of the square and the circle, and we're going to get that the square's perimeter is going to be larger than the circle's perimeter. Now, on to method 3, using similar triangles. Let's construct the following chords of the circle. We have this chord and this chord. Now, this entire triangle will have an angle that's inscribed in a semicircle. Therefore, this is a right angle. Now, that means this is an altitude on the hypotenuse of this right triangle. Therefore, it divides this right triangle into two similar triangles. This is the larger right triangle, and it has a ratio of its short leg to its long leg equal to 1/2. That's y over 2y. This will be similar to this right triangle, which must have the same ratio. In this triangle, the longer leg is equal to y, so the shorter leg must be equal to y over 2 to get a ratio of 1/2. We now have r as the radius, which means that 2r is equal to 2y plus y over 2. We then have r is equal to 5/4y, which means, just as before, we calculate the square's perimeter and the circle's perimeter, and we're going to get that the square's perimeter is larger. I know there are many other ways to solve this problem. It's a really fun one. Do check out the thread on Math Stack Exchange, and you can share your solutions over there.